So, hey guys, welcome back to the video today. I'm talking about this. X equals the square root of x plus 6. And it breaks the laws of math. I shouldn't have wrote that. Breaks of formula. So, what I'm going to do is I'm going to separate this into 3 sections. So, section 1 will be the question, and how to solve it. Number 2 will be what's wrong, and number 3 is how to fix it. So those are the 3 things, and just need to add to all of them. So what you do is to calculate this. The question, how you solve it is you simplify it to x minus 6. Wait, we have to do a square here. X minus 6 squared equals the square root of x squared. So if we simplify to this, which we can then make into the quadratic x squared plus 12x plus 36 equals x, which can be made into the actual quadratic. Can be made into an actual quadratic that can be solved with the quadratic formula. 1x squared plus 13x plus 36 equals 0. Now the quadratic formula is this. So solve for x colon. You have to do some math operators. So over negative b plus or minus the square root of b squared minus 4ac over 2a. So that's the quadratic formula. So if we plug in the values, b is 13 squared so 4 times a, which is 1, so just 4 minus 4 times LC, which is 36 over 2a, which in this case is 2a. So just 2, and then 13 squared is just 169 minus 4 times 36, which is 144 minus 144, so negative 13. So 169 minus 144 is equal to 100. No. So it's 169 minus 20, 25, which is the square root. We don't need 5 over 2. So negative 13 plus 5 is equal to, well, negative 8. And I actually don't know how I got here. I'm getting something confused. But there's another way to solve for this, since I'm bad at quadratic formula. If you take your quadratic and you take B and C, and you need two numbers that add up to 13 and multiply to 36. So you get two possibilities from the quadratic, x equals 9 and x equals 4. Here's actually a calculator, which is, since I do the calculation wrong, I can actually show you that x equals, it should be 4. Oh yeah, it's negative 4, negative 9, but x has to be positive. So x, 9 and 4. But if we plug in x equals 4, that brings us to step 2. What's wrong? So x equals, let's just test x equals 4. So we go 4. So let's go up here. Square root of 4 plus 6 is 2 plus 2. And that, is this a true mathematical statement? No, it's not. That's what's wrong. X doesn't equal 4. Why are we getting this? I will explain it later. So what's wrong is, for some reason, our quadratic, which is this, 1x squared plus 13x plus 36 equals 0, this quadratic. For some reason, it's yielding a result. So what if we go, actually, let me just undo everything, because it'll have all our old equations. So if we actually plug in 4 minus 6 squared equals square root of 4 squared, it's actually wrong here. So 4 minus 6, negative 2 squared is 4. Square root of 4 squared, 2 squared is 4, so it works. So what if we go here? 4 squared equals 12 times 4 plus 36 equals 4. Oh, this does not work. So something went wrong when we were doing our quadratic thing. And we converted this to a quadratic. 4 does not equal 8. So now we get to step part 3 of this video. How to fix it. Actually, we're still in part 2. We're doing is something called an extraneous solution. Wait. Gotta go. Wait, no. Extraneous solution. I need to find the Wikipedia page. So, let me show you. So, it's about algebra, so you can multiply both sides without changing. It's not true. If we multiplied, so we can change x no matter what. But if we... So basically, square, see here, so see, that's weird. So what's happening is we're getting an extraneous solution. So what's happening? Why are we getting this solution? So the problem lies not in what we're doing, but in the quadratic formula itself, which is one of the most important formulas in math. And if you ask me, if one of the most important formulas in math is broken because of a simple square root equation, something clearly is wrong here. That's because the quadratic formula was never meant to be used for square roots. That's the quadratic formula. So if we calculate through the quadratic formula, I just have my paper out here. So b is 13 plus or minus square root of 13 squared minus 4 times 1. So 4 times c, 36 over, well, 2a, which is 2 times a, which is just over 2. So 13 squared, 169. 4 times 36 is 144. So I'm just doing this on paper. You can't see when I 25, so that's 5. 13 plus 5 over 2 is 9. 13 minus 5 over 2 is 4. So that means our current solutions, quadratic, c equals 9, c equals 4. Those are our solutions, but as I mentioned, x equals 4 does not work. So the problem, as I mentioned, lies in the quadratic formula, and this applies to not just random square root equations that like the ones I'm mentioning. It applies to almost all algebra square root equations, and it's actually a really simple fix. If you want the value of an x to be positive, for example, our square root, which is, as I mentioned, our equation, which is x equals the square root of x plus 6. So this is our equation here. And we're converting it to a quadratic, which then yields us the result x equals 4. And how we can fix that is by making sure that the positive value, so since we're going like that, x must be positive. It's positive because you need it to be positive. So actually, let's just do that. But it's weird, and so you get this weird solution. And the main solution that I found is to just, instead of making this negative plus or minus, you need to just make it plus, so that you prevent negative values and weird stuff from happening. And that delivers the solution x equals 9. Which means, after all this stuff, it's just the quadratic formula that's messed up. And let me actually show you online. X equals square root of x plus 6. So you can go here to this thing. Let's see. So what you do is x equals square root of x plus 6. Remove square roots. X squared minus 12x plus 30. So x squared minus 12x plus 36. X equals 9. X equals 4. Verify solution. See? So I don't know what most of this stuff is, but as you can see, you do get x equals 4, and that's because of the quadratic formula. It's plus or minus. So I recommend just, if you're ever doing this would apply if you did like an equation like to say I'm actually going to see, but it applies here too. The quadratic formula, this rule applies to this random equation too, not just our equation here, broken quadratic formula, which is very weird. And it just seems strange to me that one of the most important mathematical formulas just breaks because of square roots. So the best solution to stop this is, well, just whenever you have a square root radical equation, just go make the plus or minus a plus. And you now have your answer. That's it.